So, okay, so far what we actually had done is looked into a VoIP system, a possible design technically. I have not still gone into actual SIP stuff. So, first thing that we figured out, there was a indexing server requirement. If it is a purely VoIP system where all end clients are actually on the net and they are all IP capable. And secondly, then I moved on, okay, this is actually not a proper system if you want to implement, because conventional telephony will exist for time to come. So, I introduced the concept of media gateway. Okay. So, media gateway is where if you are on the conventional side, you will see as if the system is like a conventional telephony system, or conventional exchanges are there, conventional network. And if you look from the IP network side, all conventional telephone endpoints will look like as if they are VoIP endpoints. Okay, that could be one approach, and SIP itself or any other protocol H.32 can be used to control the media gateways in that case. But usually this is not done because now maintaining so many VoIP instances in a media gateway is going to be complicated. So, a separate media gateway control protocol actually was evolved. That was the reason why Megaco actually was evolved. And of course, one more thing which I clarified yesterday was that media transport, all media encryption and whatever media will be transported, or whether you are going to do the control of the media once the session is set up, is not going to be handled by SIP. Usually it is a clear demarcation which was done, but some designs actually do not follow this. SIP by design does not do it, but Skype, for example, call control, other things are part of the signaling itself. Okay, they do not demarcate these two things. When we implemented Brihaspati Singh, we also have not done this demarcation. So, we follow a different architecture because of course, ours is not a VoIP, is not a telephony system, it is a lecture delivery system. Okay. But SIP technically can be used even for setting up of this live lecture delivery system also. SIP is very generic in that sense. So, so far everything is fine, but the problem is security. I have not mentioned about security, and I have not also introduced, I have introduced in a sense something called registrar or indexing server. I have not introduced so far what we call proxies. Only reflector node I have told what is a reflector node. Reflector node is for media streaming. So, when I said that when you are behind a firewall in this network, you want to talk to somebody who is also behind a firewall. So, they cannot communicate directly because only outgoing TCP connections or UDP connections can be set up. Incoming it is not possible because these gateways usually will never permit an incoming connections. Okay, even if you send a UDP packet, unless there is a table entry here mentioning that a packet which is coming on this particular IP address and on this port number has to be transferred to the destination port number, and IP address has to be changed to another entry. So, there is a corresponding inside entry and there is an outside entry. So, inside IP address entry will be for all the IP addresses which are used inside, port number used by the actually the client. Outside is the IP addresses, it can be one or it can be multiple, a bunch of them which can be allotted to the netting router, and the port number. So, these maps are usually unique, and that is how the translation happens here. So, incoming will be permitted if this table entry has been made. So, usually it will be done if, for example, you want to send an UDP outside, then on the reverse actually the packet time can come till the time this entry is made and the policy permits it. For UDP, TCP you can only set up the connection from inside to outside, outside to inside usually it is not permitted, okay, because table entry itself will not be there. So, you cannot set up a connection from outside to inside. So, usually something which is there on the internet will be used. So, this guy will set up a connection all the way to this node, this guy will also set up a connection to this node. Remember, these will initiate and these will now maintain the entries, and this will act as a router peer. We call it a reflector, a juxtapose JXTA terms, we call it a router peer. A router peer is router peer, some people call it reflector. some people call it super nodes, but technically they are all same things, they are different terms actually being used, because there is no standardization of terms. Now in VoIP system, this is we actually can have something, is we call it a media gateway, is connecting two medias, but most of the time this transport will be, can be UDP, TCP, but if you are, this is not a netting gateway, it is a proxy router, this will be HTTP tunneling. So this HTTP connection will be periodically fetching the whatever is stored here and keep on through a post method, keep on pushing the information. So that is what I mentioned. SIP does not bother about it, SIP assumes that two endpoints can talk directly. If they cannot talk directly, it has to find out a intermediary, and they should be able to talk to intermediary, and intermediary can do this. Whether they will use HTTP tunneling, UDP, TCP, that is not the headache of SIP. Headache will only give the session description, and the endpoints, once they are connected through a signaling path, they have to figure out how they will set up this connection, whether they will use a reflector or not, whether they will use HTTP tunneling or UDP or TCP for different media streams, is they have to decide by negotiation between themselves. For negotiation they can use SIP. In our design, we actually have an intelligent client which figures out whether you are behind a proxy or not behind a proxy, and based on that it automatically switches over to one of the two options. It is not through negotiation between end pairs. Okay. So this is slightly more conservative kind of design, not very flexible. Skype also does the very similar thing. The client figures out whether it is behind a proxy or it is not behind a proxy, whether it is behind a netting router or not behind a netting router, and based on that actually it will figure out what will be the connection mode. So Brihaspati sync system is very similar to Skype in that sense, the client capability actually. SIP does not bother about it. SIP is, the end peers have to negotiate and figure out what is the best method, and they will do it that way. Okay. So I think that till this part we had come so far, but again before I move over to, because there is still a question, somebody can always make fool of the system, can enter into the system. How you will know that other guy with whom you want to talk is actually that guy? Indexing server with whom you are trying to talk is actually the indexing server. How that problem will be solved? I have not talked about this thing so far. So what I am going to do is I am going to give a generic security system, because I think that is an essential requirement before we move forward, and then we will move to SIPs, basically SIP architecture. What is that? So fundamental principle, let me actually, one of the simple idea of in security system, one thing which we always need to do is authentication. So you verify who is the person who is trying to talk. Okay. So who are you basically? That is a question which will be answered. Second thing which one always need to look into this thing is authorization. What you can do, what you are permitted to do, that is the answer which will be given by this mechanism. These two things usually need to be answered. And in any security system, the best thing is that you always become very conservative. You do not worry about the whole system. Usually I have seen this thing happening even with the lot of students when they build up their projects or they write software or they build up a design, they actually assume lot of things. So this should never ever be done. So whenever you write a distributed system, you assume you are an entity which is participating. That entity will be transacting with lot of other entities. For every transaction, it has to be ensured that other person with whom you are transacting is the person who actually he is telling that he is. If he is saying I am so and so ABC, he should be ABC. But that is one thing, and secondly you have to check with your own access control list, usually we call it ACL, your own structure, data structure, or somebody to whom you know again that also has to be authenticated. From him he has to get what all permissions has been given to this person, and based on that you will allow, but it is your discretion. So, you have to actually safeguard your own local domain, every entity has to do that in distributed system design. So, if you have multiple entities, you have to now think as if you are each one of those entities and see if you are satisfying this particular requirement, that every transaction which you are making with anybody, you are checking who is the other person. You should never miss out even one single operation where you, if you are not doing that, you are vulnerable, and you should always check whether authority has been given to him or not for doing what he is trying to do. Is basically he is trying to execute some command by sending a message, you are doing something and sending him information back, you are responding. So, you will only respond successfully if he is authorized to execute that method, and when you are going to request, other person is going to check. So, this is if you are acting as a server. So, requesters only you are verifying. Now, there is another thing, not only requesters need to be verified, when you make a request to somebody as a client, you have to always ensure that you are requesting the right guy. Somebody who is spoofing can actually say I am a server, he is sitting in, and you have a faith in him, you go at that particular place, pass on all the information, then he can manipulate everything. So, even when as a client you are connecting to somebody, say indexing server, you should know this is the right indexing server, what he is saying. Now, how this will be done? So, how you know that www.gmail.com is actually the Gmail's server? What you are getting is www.gmail.com is going to domain name services, in turn you are getting back an IP address. How do you know this is Gmail's IP address? You are querying only IIT Kanpur site, and if some student hacks our DNS server and gives a different IP address, puts up a server in IIT Kanpur itself, so you will get that particular server's IP address, you will log in, and if he can create the same GUI, you will say it is a Gmail, you will put login password and password will be trapped. DNS poisoning, this is what we call. So, DNS actually can be a one of the most weak links in this kind of system. So, we have to even take care of this. So, what is the most basic system for authentication which we use, which you are aware of? Login and passwords, right? Okay, shared secret we call it. And there are two ways of handling this login and password mechanism. We call it a challenge and response. So, usually what happens is most of the systems, for example Gmail, when you go there you have to first of all do a login and password you have to provide. You try whatever it is, it will always come to this default screen. Okay. And once it comes to default screen, the problem is you have to put your login password as session key will be given to you, and after that session will be tracked on both sides, and so far you give the right session key, that side will know who you are. So, your identification is bound to the session key. So, with now every transaction you are not being authenticated, remember, only in the first transaction you were authenticated, a session key was given to you, it is known as cookie actually in a web browser system, and that cookie is always transacted, and cookie expires, a new cookie will be given, and with that he will know that who you are for the whole session till you log out.
But once a new cookie has to be generated, then again authentication has to be done.
Not necessary. I am now coming to that picture. Now, in certain web servers you have logged in, for example Facebook is a very good example, Facebook, LinkedIn both actually use the same thing. You have logged into the system, you do not log out, you just simply close your browser. Next time you start the browser, go to www.facebook.com, and interestingly you will find out that the guy still remembers who you are and he just logs in into the session. You do not have to give a login password. How that thing happens? Because it is using what we call persistent cookies, which are there for certain time. There is a random string. So, when you do a login and password, login, that time that cookie random string is generated by the server, given back to you, and this is stored in your browser. So, browser, if you look carefully, cookie is stored for, cookie is a random string for a certain site. So, whenever an HTTP message is sent, HTTP request is sent to that server, this cookie will be going as one of the fields in the HTTP request. So, whenever you try www.facebook.com, your browser by default has a cookie for Facebook, it will send that cookie to that Facebook thing, and that Facebook guys looks at there is a cookie which has come along with the request. So, must be session must be on. So, once the session is on, it will search this cookie was assigned to whom. So, it will then figure out from the database cookie was assigned to you, and most likely the same cookie is only assigned, that cookie is only assigned to you, is a randomly generated string. Remember, if it is by chance assigned to 2 persons, you might end up in logging in somebody else actually, that is also possible. But that chance is extremely rare because cookie is pretty long. So, if you look at cookie at any point of time, there is a large number of characters and each character require 8 bits. So, it is actually is a very large number, much larger than the total population on the earth or total number of logins in the Facebook system. So, it is pretty much safe system. Okay. And of course, once in a while you will find systems where even if you log in, suddenly in the in between they will ask for verification, because actually there was no login, it was using a persistent cookie. So, they will do a periodic check. Gmail usually does this, once in a while suddenly you will say blank screen, you have to log in to further continue. Yahoo also do the same thing. Now, banking system do not use this kind of mechanism. Banking system, if you try to go to another back screen or try to do, you can never do this. They are doing still a smarter thing. Now, every HTTP request will send a cookie. When the response will come, a new cookie will come which will get stored, and that cookie has to be used for the next response. So, for every transaction, cookie keeps on changing. The moment you try to use a back button or something which is going to an older page, for that older page it will not permit, because it actually remembers that when you do the back, the older request is going which is having a different cookie, older request command is sent actually. So, unless the new cookie goes, it will not accept. So, you can only do the forward transactions, you cannot go back actually. For every request there is a separate cookie, new cookie gets generated, and with every response a new cookie comes and replaces. So, it is not a persistent cookie, it is a non-persistent. So, if you log out and log in, the older cookie will not work, and it only works for certain time. So, if you are not going to send another HTTP request within certain time, they will time out and remove the cookie. That is still better security system. But there, as of now, what I am telling is, the server is authenticating you, but how you are figuring out that Gmail is actually Gmail? It is not being created by as a phishing site or something by the server. Now, that is where the concept of security certificates will come, because I think this is extremely important. Most of the peer-to-peer system will ultimately, or are actually they ultimately going to use security certificates for authentication.
We are talking about two-way authentication rather than one-way.
Yeah, there has to be two-way. Your machine actually is doing two-way authentication when you are logging into Gmail. And how it is done for Gmail? You are always using something called a HTTPS. Okay, you are not using HTTP, you are always using HTTPS if you carefully observe for Gmail session. Facebook session you should be using HTTPS. If you are not using, you can be vulnerable to phishing actually in that case. Phishing is different in the sense, phishing is sending a URL in the email which is hidden as an link behind certain text. So, sometimes if you know where it is being redirecting, once you click on there, you can figure out this URL is not matching, and never ensure that you never try HTTP. So, whenever you are doing banking or anything which is requires security, you need to authenticate a server, make sure it is always HTTPS. HTTPS does two things. You can authenticate a server, and you can also create a encrypted channel from your browser to the server. because that is also one of our requirement. I have to authenticate user, I have to authenticate servers, servers have to authenticate another servers, and I have to also always keep the channel secure. Remember how the two clients are going to get connected. The indexing server will tell this guy, the other guy is on this port and this IP address, you will tell him this guy is on this port and IP address, then they will make a connection. When this information is transacted, only indexing server is knowing, and you have faith on indexing server. If indexing server is spoof, what it can do is it can now use a media gateway in between, route this call to this and this guy's route call here, and it can do the tapping of the call. So all snooping will be done, can be done in that way. So if you can, and this can be done if you tamper with DNS. So DNS is the most vulnerable, so don't believe on DNS. DNS only gives from a name and IP address. Once an IP address comes, then you have to further verify that guy, whether that server is authentic or not authentic. So how that will be done? You can give a login and password, but how that guy will give a login and password to you? Gmail cannot log in into you, and you cannot, so Gmail has to remember all login password for so many users and provide them a credentials. No, it is not going to be done that way. So we use something called certificate. So you have, all of you have actually ID cards. Well, now I am coming to this concept. These ID cards are usually signed by Dean of Student Affairs, and Dean of Student Affairs ID card is signed by Director. Director's ID cards are signed by somebody, I think chairman of the board. His ID card must have been signed by the somebody in the ministry, and his ID card ultimately it goes to the President of India who is the first citizen, and we assume that everybody knows how the signature of President of India looks like. So it is a well known signature, well known public key, or we call it. So it is extremely important. Similarly, it is like bank notes. Bank note is nothing but a piece of paper, or technically speaking. What is important is there is a promissory note written on that, and there is a signature by RBI governor. So I can also prepare a note and I can sign with my signatures, you won't accept it. It is only RBI governors, because essentially he also has been given an authority through a certification chain. So this is what we call concept of certification chain, and there is always going to be somebody who is a master on whom everybody is going to have the faith. So this is what we call certification authorities being created from root onward till the user certificate, which is going to be used for authentication purposes both ways. Now when you talk to another guy who says I am also from IIT Kanpur, you also say I am from IIT Kanpur, how you verify? Both of you exchange, show your ID cards. So you know exactly his name is XYZ and that is written on the ID card, your name is ABC because that is written on the ID card. So you cannot fool each other. Verify each other's ID card, both of them have signature of Dean of Student Affairs, perfectly fine. Both of them, if you are aware of the signatures of DOSA, so you verify. Unfortunately, he does not have a photocopy or a copy of DOSA certificate. So if DOSA changes, you do not know. If you do not know the DOSA signatures, you are doomed. But somehow you can go to website and verify his signature and so on. If the verification can go till the root, it will be fine. Everybody need to know only the root authority's signature. So this is the essential trick which we will use. So root authority for security certificates are existing. One of them is actually VeriSign, then many of them are there. VeriSign is the most popular one. So lot of agencies become certification authorities, and you can apply for a certificate and you will get a certificate. But what is a certificate now? So we use something called PKI, public key cryptography infrastructure actually in this case. There is only one problem here, the certificates when they are revoked, and if you cannot verify the revocation list, then there is an issue. We will also face the same problem actually here. Nobody has a solution, but we assume that most likely problems will be very, very rare. And whenever you have a chances of revocation, make sure the certificate validity period has to be small. So there is a very small vulnerability period which will be there. Only very few people will be vulnerable in that case. So in PKI, public key cryptography infrastructure we call it, we can always generate two keys, Well, I am not going to go into details of how this is done, but this is technically possible. So, there is a key pair, public and private key. So, there is a method by which this can be done. Now, important thing is I can generate something known as keyed hash. So, before this, what is a hash? Hash is you take in whatever is the box, which is this hashing function, you push in whatever is the input, it can consist of any number of strings, it is immaterial, and there is an iterative procedure by which you can compute, and you will end up in getting a say 128-bit hash. So, 128-bit code you will get after this. So, all possible messages which are there or a sequence of strings can be mapped onto 2 to the power 128 possibilities, if it is a 128-bit hash. So, many messages will map onto the same hash, but I need to have only 128-bit, that is important. Message size is independent. Now, one of the important thing, there is something called keyed hash. I can input something and I can also input a key, and I can generate a keyed hash. Even if the message is same, if I keep on changing my keys, my keyed hash will also be different. Okay. So, very simple thing, if you remember certain key, I also know that key, we share certain key, and you send a message to me, message is not encrypted, but you attach the key, generate a keyed hash, you send me the message, you send me the keyed hash, anybody can know it, see, no issues. Once it comes to me, I also know the same shared key, so I can put that key along with the message, generate the hash, this hash will be the same which you have generated and sent it to me. Somebody tempers the message in between, message now consists of message plus the hash. If hash is modified, it will not match, I will discard the message, it has been tempered. Message is tempered, then also hash will not match. He cannot temper with the message, cannot generate a new hash, because only 2 persons are knowing the key. So, this is going to ensure the integrity between the 2 people who share a secret.
Again, the problem is private secret.
Abhi I am only talking about a shared secret, common key. I am not come to this public and private key thing.
My question is how we exchange the keys together.
That is not required, I am coming to that situation. I can verify message was sent by you. I have not still come to public and private key business. So, this is what we call integrity check, and if you want to actually do encryption, you can actually also use this key to do this encryption. There are methods available. So, you will get encrypted message, and on encrypted message or unencrypted message you can also generate a hash, and that hash and encrypted message also can be sent. You can verify because you know the key, no tampering has been done. First thing you have to always, even for encrypted message, if you are sending an encrypted message for me and there is no hash, for me to damage the system is very simple. I can change some characters, you will decrypt, you will get a wrong message. You have to always check also the integrity before you do decryption. Encryption only hides the message, encryption does not check integrity. So, integrity check is separate and security is separate, they are 2 separate things. So, this is tamper proofing. Now, if I have these 2 systems, I can always use a private key here. Okay. I will get a message plus keyed hash, this can be transported. I can again push in whatever is this message which has been received, and I can put now the public key. Only thing which I can verify, I cannot generate the hash because if I can generate the hash very well, I can modify the message and generate a new hash and send it actually. Hash can only be generated by private key or the other way around actually. Either this will be private key or if it is, it can be a public key. So, if I am using private key for generating the hash, I can only verify the integrity with this, I cannot generate the hash. So, integrity check will be done here. That ensures if public key from can be used to verify that the proper hash is actually proper, whatever is the current existing hash is coming is proper or not proper, only that thing can come. I cannot generate with this actually the same hash, otherwise technically there is no security.
How are we checking integrity?
No, when this message plus hash, these two things are going to be pumped in, sorry, I put it public key, I can get an answer yes or no, whether match happens or does not happen. So, what the yes and no, if it is yes, it says whatever was the corresponding private key, indeed that was used to generate the hash for this message plus hash combination.
This hash is encrypted with the private key?
No, it is not, it is available, it is open. But if you for example tamper with the message, you do tampering with the message in between, the incorrect message plus hash when you will generate, I know what is the hash bits, I can this whenever I will use public key it will give an answer no. I cannot generate hash with public key if it is already generated by private key, I only can get answer yes and no.
How we are getting yes?
The way you do CRC.
What is hash actually? What is hash?
Hash is a mapping, is a nonlinear mapping, many to one map, many to fixed number of mapping. Well, for example, yeah.
How is hash is different from signature? Where in signature we also do the signing by the private key and verifying by public key. Then we
Hash is signature only, na? Hash is signature only. Hash is signature only.
with signature.
Yeah, right.
Verifying with public key, getting the answers.
Right. Public private actually hash is keyed hash are slightly different because of this. So, you cannot generate keyed hash. If you generate with public key, you have to verify with this private. If you generate with private, you have to verify with public.
They are both sides of the same coin. Both sides of the same.
There is a pair. This actually is more computationally complex, that is the only problem.
The only difference, when we are doing encryption, so we are encrypting the public key and verifying with the decrypting with the private key. When we are signing it, we are.
Whenever I am sending a message to you and I want only you to understand the message, I am not talking about encryption as of now. Encryption will never be done with a private key, I have to tell you. One of the very important thing, if I start doing encryption of a long message with a private public key pair, it will be computationally heavily inefficient, it is never done. So, what is the way it is done is, I will send you a symmetric key which is used for encryption of a proper of the message. Key is not known to you. For that small key only I will use your public key for doing the encryption. Nobody else knows your private key, so other people cannot decipher what was the key transferred to you. With your private key you will now decipher, first of all decipher the key, and then with that key the remaining message will be decrypted. So, message can be securely sent to you, but you have not figured out that whether the guy who has sent you the message is authentic or not, you have not verified that. Only thing I have ensured, it has only the right guy can actually get the message out. If you also have to identify whether I am the right person who have sent the message, there is another operation which need to be done on this. So, I have to now sign this whole thing with my private key, you will know my public key, and with that you will verify whether it is the I actually who has signed that thing or not. But you also are having a faith, because whatever because my public key is known to everybody, but private key is not known. But how do you know that my public key is correct? So, I am now coming to that certificate thing. What technically certificate is? So, this is what we call, basically this mechanism will be used for encryption, this will be used for authentication both ways. Now, what is a certificate? Certificate usually will contain what we call details of, say, server for example, it can be anything. So, but mostly when you go for www.gmail.com, certificate says this certificate is for www.gmail.com, this is having this particular IP address, okay, and this certificate will also contain a public key of this server. Private key is only known to this server, public key of this server. Then it will also contain that it has been signed by VeriSign. VeriSign's public key must be there with you, okay, it must be there with you, or if you have only VeriSign, but this guy has bought something from MTNL for example or BSNL, it has bought the certificate, it will say this is being signed by a certificate of BSNL. BSNL's public key is this, and BSNL certificate has been signed by VeriSign. VeriSign's signature will be there, and VeriSign's public key can also be there. And I can always verify that this thing will be a stored certificate in your browser. It always updates periodically. In Windows, Microsoft Windows, its update whenever the Windows update will come, that time these certificates will, root certificates we call them, they will get updated. Whenever you will update your Firefox, that time Firefox internal certificates get updated. You can even install your own certificates. So, if you have faith, you accept it. For example, if you do HTTPS for Brahaspati Sync or Brahaspati, it gives you a certificate, that certificate is not signed by VeriSign. Your browser will immediately give a warning, this certificate is not signed by VeriSign, it is only a self signed certificate, would you like to accept it? Do you have faith on the server on which you are connecting? Okay. So, in that case, usually my purpose is not for server authentication or this thing, because I am not maintaining those kind of critical info, it is not a financial transaction for that matter, you are only looking at course material, but you want your password should not be seen by some intermediate guy who is sniffing on the channel. So, that certificate once it comes, the public key of the server is available, private key is with the server, which I have actually installed in a file, and that file is only read only for that user, it is not visible to anybody else, I have hidden that actually there. So, these two things, public private key, will be used to create a shared secret between these two. So, what happens is they actually exchange some random strings, and these random strings are passed, I think, unencrypted as well as encrypted both ways, and both of them will then compute using these keys, shared secrets which have been transacted, common shared secret. Actual shared secret is never transacted over the thing, they compute it, and both of them will in turn will compute the same key, and that is what will be used to create a secure channel. So, nobody can tamper, nobody can sniff what is being transacted. So, before you do login and password, currently if you do not use HTTPS, your login password can be seen by anybody who can sniff on any router or any switch. If you use HTTPS, then it cannot be. No, it is HTTPS. That is kind of mistake that those people won't do. I am sure that is HTTPS, I have been using that. I think most of the servers are HTTPS. Okay. Now, this is the kind of certificate which will look like. So, you have already logged into something, you know the what is the destination IP address from source IP address from which it is coming, this was the URL which was used, and this guy will also, you will can send him a random string and ask him, you kindly sign it and send it back to me, I will verify with this thing. So, that is possible, or what you do is you say ask him to send me a random string as well as a signed version of it. So, he sends a unencrypted random string and the hash of that, these two can only be generated by that person, nobody else can generate, third party cannot generate because it will not match with this public key, and that way you know this Gmail actually is gmail.com, it is not somebody else. So, that is a very simple check which can be done, and that is how you will authenticate the server, and it is always you will fulfill the chain till you find out that ultimately somebody has signed this certificate chain whose public key is there in your key store, in your certificate store. You can actually see all these tokens, these are known as built-in tokens, security tokens in the browser. In fact, this need not be browser, this can be even your software which can do this job. So, Brihaspati Sync client actually does that, it is a Java client written in Java, it actually also does the same thing, it checks for the server. So, we do check the authenticity, and especially we have been actually using a trick that it is not that anybody can install an indexing server and you can start using it. You cannot, because we always run a master where all indexing servers in the world have to be listed, otherwise you cannot join a Brihaspati Sync client session actually, it is not possible. So, we have done the system in that way. So, I think this is what will be the basic framework which will be used. Now, there is another important thing, we are talking about peer to peer systems. So, one way, as I told, I will now use this security certificate mechanism for authentication with clients. So, Skype I think technically has been doing, because of the way it behaves, that gives a guess that most likely it is using a very similar system. First time when you will start the client, you will always get a login and password. If you actually have a certificate issued to you by an MTNL, where the certificate chain can be verified till the root certifying agency, then it is fine, you can install the certificate and you can always generate a random string, sign it and send both to the other guy can verify from your certificate can be verified through a certification chain and he knows you are ABC. Other guy also does the same thing and you know he is also XYZ. But that actually means every user in this world require a certificate, and not only requires a certificate, he also has to remember a long private key. So, remembering a password itself is difficult if it is more than 15 or 16 characters. So, you have to have some sentences, you will take first and last alphabet all combinations and you remember it that way by using, everybody has its own algorithm of remembering the passwords. So, 128-bit hex key, if you are going to remember, is going to be hell for a persons. So, usually you get a USB stick or something as your where the private key is stored, if that is lost you are gone. And then what you will do if it is lost, because now private keys has been compromised. So, we create what we call CRV, certificate revocation list, okay, CRL we call it, yeah. Now, this is maintained at the certification authority, whichever is there. So, whenever this certificate will be presented, your browser, if it is connected directly to the net, will actually try to connect to this server which has signed this, find out the CRL there. In fact, it will keep on doing it till it goes to the root, and root will maintain a CRL, it will verify that none of the certificate should be there in that certification revocation list. Certificate expiry will be part of the design, and since it is already signed by certification authority, it cannot be tampered with actually. And usually the procedure is that when you want to generate a certificate, you can do it on your machine actually. So, you can put all the entries and everything, and there is open SSL utility which comes, okay, is available on all Linux boxes. So, you can generate your own certificate and you will generate your own private and public key, private key will be there in your file. Now, this certificate you can submit to the site, you have to also submit all your documentation, they will verify these addresses and everything, all things are authentic, and then he will sign with his private key and signed certificate copy he will send, which then you can use. Your own certificate also you will be signing with your own private key also, to ensure even so others guy cannot tamper it, and this whole package itself will be signed by somebody else, and he will attach his own certificates and sign. This is the way everybody keeps on doing it. So, you have the complete chain because of that. it is your choice, people can have, it is actually from say few days to 12 years, 13 years. So, that depends. If you know that there is a possibility of tampering with certificates, certainly you will actually keep a period to be very, very small. So, if you keep it one day, suppose even if you lose the key, you will generate another certificate next day. So, only if at that period, say you lost it in the afternoon, so midnight anyway it will expire. So, 12 hours is your vulnerability period. And in fact, there has been a case once where a root certificate, I think of in Holland, was compromised, and that was I think one of the biggest disasters which happened. That was the only incidence which I am aware of where the root certificate was compromised by hackers, and that is it if that can be done. If you know the private key, it is okay, then you can be very nasty. They can be. The private key is there inside. Once the private key is lost, it is gone. If you are not remembering it, you have not written on a sheet of paper, it is gone. Best is you remember in your mind. Unless you lose your memory, it will be there, and nobody can read your mind. Till that time, it is fine. So, CRL is one of the key components. So, in fact, sometimes what happens, if you lose internet connectivity, you are using a certificate, it will actually give you a warning if a browser has been configured properly, that I am not able to verify CRL. So, certificate which you are using may not be correct, especially if you are reading some document and that requires a certificate to be used to take care of the integrity of the document for integrity verification. Typically, this problem comes when you take the Ethernet port out if it is not on the net, because it is always dependent on the network for doing CRL check. Now, this is I think is the only problem, and we do not know the solution of this. So, usually whenever you will buy a certificate, you have to pay I think 2000 something rupees in India, and any of us, one of us can buy a certificate. We have to submit our PAN card copy, identification document, everything, and then they will give you the certificate. In fact, if you are going to run a company, it will be mandatory for you, because your income tax returns you cannot file unless you have that certificate with you. So, it has not been made mandatory for the employees as of now, but maybe in few years down the line it will be made. So, we have to also buy certificates. Okay. So, now this is a problem. So, everybody will not have certificate. So, how the Skype works now? Question is this: there has to be some intelligent solution. So, you have at one end login and password, other end you have certificates. You can make some kind of a hybrid combination. So, what Skype does, whenever you install Skype, Skype has its own built-in root authority. It is not VeriSign. It has its own built-in authority. It comes programmed, and hopefully this will never be compromised. If that gets compromised, then of course it will be a big trouble for Microsoft as of now. Earlier it was Skype. So, the way it is done is, whenever you log in for the first time, you do not have a certificate installed. Certificate remains till you log out from the system. Once you log out, once you technically exit actually and terminate, or your session expires. So, you will actually do a login. This will go to a server. This is a hard coded server again, okay, inside the Skype client. In fact, there is a list of servers which is maintained, indexing servers. You go there, you do login password. It is maintains a secure connection, HTTPS or connection most likely, and login password is sent. You are verified from the database. Whenever you will change a password, it should actually communicate back to the server. So, once you do this login, this will generate a certificate for you, whose private key will be stored in your client. Certificate will be presented, and this certificate will be self signed here itself, and it will also be signed by the private key of the Skype. Public key of Skype is already available to all clients. So, once it is done, your certificate comes and gets installed here. Now, when two Skype clients want to talk to each other, they can authenticate very easily. In fact, every device, every Skype client or a Skype super node or super peers we call it, actually have a certificate. So, I also hack the code of Skype, put everything, and then I start running it, and I feel that this Skype will contact me, this Skype will contact me. No, this will not happen. They will not recognize me actually, because I do not have a certificate installed, which is signed by Skype's central server. But the beautiful thing is, if the server is down, I am not on the internet, I am on LAN, I can still connect if somehow I can find out the other Skype peer. I can authenticate with each other using certificates. Now, this is also the genesis of Brihaspati 4 design, which is peer to peer serverless LMS system. So, a similar structure also actually we have converted, there was no other option for me. I tried all kind of possibilities if they exist. I figured out login passwords are not going to be possible. If a large number of users all across the world maintaining a server and authenticating everybody at every time, I need to maintain a large infrastructure in a peer to peer system, and that will not be financially viable. But this makes the things financially viable. Only thing is that I issue a very short thing. So, periodically depending on how many users are active and how fast I can, how much load indexing server can take, we ensure that timeout or the expiry period of the certificate is updated, and when certificate expires you have to log in again and get a new certificate. Skype actually does this. Once in a while Skype will log out and then say ask you to log in again. This behavior I have observed actually, I do not know whether you have observed or not, but this is the most likely reason for this thing. So, now when we will build up a system, most likely this is what is the technology which we will be using. So, advantage, users need not buy a security certificate from a certification agency. I bypass certification agency altogether. So, it is like everybody knows the director here, you need not go to the President of India and issue certain ID cards, and we all recognize each other through those ID cards. It is a local authentication, group authentication inside the system. Okay. So, I think now we understand that the servers, how the servers can be authenticated and how the users can be authenticated. Okay. Authorization issue, yes, that is one more. Authorization in case of SIP systems usually is done through SIP registrar, because this usually is a service provider which will permit you and you have to pay to him for those services. For usually it will be all kind of services, it is a peer to peer. So, whatever the two guys which agree on the kind of service which they want, they can actually connect with that kind of service. And of course, now you should also think slightly bigger, it is not only voice calls, I can ask for another peer, it is actually technically a SIP is creation of sessions between peers. So, I can ask for even for a virtual machine being provided by the other peer to me. So, I can give the compute jobs, he does the computation, returns back the result to me. I can make multiple connections or multiple sessions and I ask virtual machines from lot of people. So, computing itself can be sold. I can do transactions with other peer. It is like it is a marketplace. You go and you want to buy something, a service. So, you can buy a service from the way you buy from websites, you can buy directly now from the peer clients. But for initial setup you require a SIP. So, the tomorrow's on Saturday's lecture, if time actually permits, we will actually move and look into SIP setup mechanism. So, how the SIP actually goes, we will look into the SIP header structure and the interpretation of SIP header. Okay.